On the front of your notes packet, I'm going to have you guys draw something. I think your packet is pink. I want you to draw a large umbrella. The only thing we're going to draw, so it can be kind of big. The reason it's an umbrella is because there's a big umbrella topic and 4 subsections. So the title of activity 9 and 10 centers around this big word, transformation. So I want you to write that above at the top, transformations. We did a brief intro of this in our last lesson. Transform means to change. That's why it's the umbrella topic. There are 4 ways we're going to talk about changing a figure. The first one is translation. Sounds similar, definitely different. Translation, which means to slide. We're going to focus on that today. Our next lesson is, I'm going to do it in the right order, reflection. Reflect, which is like flipping. The next lesson will be rotations. A rotation is like a spin. Finally, dilation or dilate. In parentheses, maybe we'll put bigger or smaller. So the fourth one will not be studied for a while because it is different. So it's under the umbrella, but we're not going to study it right now. The reason is these first 3 are what we call rigid motion. We talked about that in the last lesson. Rigid motion. Does anybody remember what that means? Inside. Yeah. It means to preserve or keep the same size and shape. So if you look up here, if I take this pen and I translate it over and down, is it the same size and shape? Sure it is. If I reflect it, let's say I reflect it, still the same size and shape. If I rotate it, still the same size and shape. That's why they are rigid motion. That's why we study these now. Dilation falls under the umbrella because it is a transformation. It's a way to change a figure. I can't do it with my markers, but we're not going to study it now. We will later. So it means to get bigger or smaller proportionally. All right, go ahead and flip to then today's notes 9-2. I would say in terms of difficulty, today will be the easiest. It's not going to get super hard. I don't think any of activity 9 is going to be too tricky for you guys. I would say the easiest, then reflection will be the next easiest, then rotation. Can be kind of tricky. It's harder to visualize rotations. Here we go. You can follow along. Maria marches with the band. At the start of the halftime show, her position is 2-4 on the coordinate plane. You'll see there's an X at her position. She's over 2, up 4. Then Mr. Scott tells everyone to move 2 yards to the right of the field and 4 yards up the field. The band's transformation is shown in the diagram, and Maria's position is marked with an X. So her old position and her new position. This type of transformation is called a translation. You'll see the vocab down here in the corner, a translation is a rigid motion in which every point is moved the same distance in the same direction. On the coordinate plane, a translation is described by the function of the form blank. Sorry if you can't see up here, but you can look at your page. You saw a lot of this in the last lesson. That's how we write transformations, in which A and B are positive or negative constants. In this example, A is 2 and B is 4. I would like us to go above this table and write down our function. X, Y, arrow. And then it told us way up at the top, we're moving 2 yards to the right. So that's plus. And then we're doing 4 yards up the field. So that's the Y direction is going up 4. So I'm going to write X plus 2, Y plus 4. Based on the directions, it says I'm moving to the right 2 and up 4. That's how I got X plus 2, height Y plus 4. That bottom paragraph there says, you can think of a translation as a figure sliding up or down, left or right, or diagonally. Now, how do we do diagonally? Because we haven't learned that yet. We'll take a look up here. If Maria is moving over 2 and then up 4, do you see how that's kind of the same as just moving diagonally? I'm never going to say move diagonally 7.5. I'm going to say move left or right and then up or down, and that could be viewed as moving diagonally. I'm right here. During the translation, every point of the figure moves the same distance in the same direction. This distance and direction is called the directed line segment. That's what I just showed you. This is the directed line segment. It says if Maria is moving over 2 and up 4, everybody's moving over 2 and up 4, which makes sort of that distance there. Complete the table to show how the translation affects the 4 marching Cougars. So we have Maria at 2-4. Let's do the function. So we're going to take our X and add 2. It says take your Y and add 4. So very basic. Joe is currently at 3-7. Follow the function or rule and write down his new position, and then fill out the rest of that table. Hopefully you're a little bit careful on the bottom one. You can see we have to go backwards. This is her final position. We need to go backwards. Where was she? So do the opposite. Instead of adding 2, subtract 2. Instead of adding 4, subtract 4. Her original position was 5-7. I believe we're on the top of the next page now. Mr. Scott arranges the band in a rectangle. Then he directs the band member at 6:10 to move to 4:13. The number on the coordinate plane shows yards on the field. Here's the question. For the band to move in a translation, we're all sliding together. How should each band member move? We're basically asked, what's the formula? What's the function? So think about that. Look at where somebody started, where they ended. See if you can write the function. And the x started at 6 is now at 4. So that sounds like I subtracted 2 in the x direction. The original y was at 10, is now at 13. So that was adding 3. Another pretty basic question, just what are we doing? How are we sliding? We're using that function. Don't even need to draw anything for that. Go ahead and read number 3 to yourself. You do not have to explain. A simple yes or no will be fine. Maria, her friend tells her that her function is described as x plus 3, y minus 2. Is her friend correct? No, I don't even know how her friend got that. No. We are not adding 3. The correct way to do it would be, it looks like we added 5. In the y direction, looks like I subtracted 4. So I don't know where her friend got that information, but it's way off. Four and 5. Now the directions are going to sound tricky. They're really not. There's just some vocab up there. Let me read it. Draw the image of the figure under the translation described by the function. So if we break that down, draw the image. We have the pre-image. We're drawing the image of the figure under the translation. So we're sliding it. Described by the function. These are what we call functions or rules. So it's basically saying slide that around to get your new picture. I did not have these labels. Please label them with me. Let's all do it at the same point. So let's go to the bottom left. Call it A. Go around in a circle clockwise. While we're at it, let's label our triangle. Let's go to the bottom left is A. Go around. Here's what we're going to do. We're going to follow this function, which means all the x's we're going to add 4, and all the y's we're going to subtract 4. And we talked last lesson how we could write out every point, perform the function, write the new points. That would take a lot of time, right? You can do that. If it's just a translation, you're not required to do that every time. You can just go ahead and add 4 in the x. The x direction goes this way. Adding means you're going that way. So I'm going to take point A and I'm going to move it over 4. 1, 2, 3, 4. Down 4 in the y. 1, 2, 3, 4. And I'll call it A5. Go ahead and move point A. Now move point B over to the right 4, down 4. Then do C. Now, if you look at mine, I have 3 points done. Can you guys tell where point D is going to go without me sliding it around? I'm just going to complete the figure. You can do that. You don't have to go over 4, down 4, every single dot. If you know what your picture is going to look like, you can just put your last point in. You do need to make the rectangle. Make sure you have them labeled A prime, B prime, C prime, D prime. That tells me where A is, where B ended up, etc. Okay, please do number 5 on your own. Pass it down all the way across. You will have questions as easy as that on your quiz. If you're translating, it doesn't get very difficult. You're either moving left, right, or up, down, or a combination of, which kind of makes it look diagonal. Now, if you would flip to the very back, I think, in your packet, the very last page, I believe, you will see 3 images that look like this. This triangle, this trapezoid, and hexagon. You are getting what's called patty paper. It's pretty much like wax paper. It's going to be helpful. Patty paper will be available for you to use on a quiz. Many students have found it helpful. We're going to use it today with our translations. It's not always helpful for some students, but some like it. I think it's going to be really helpful when we get to rotation. So we're going to use it every day so you get comfortable with how we use it, and you can use it whenever you want to. So the reason we need patty paper is because we don't always translate on the coordinate grid like we did here in 4 and 5. It said move over X and move over Y, and we had an XY grid, so we moved it. If you look at the page that has these figures, there is no grid. So it's going to look a little bit different, but we're still sliding. So you won't see a function that looks like this because there is no XY grid to move it on. We're not just going to guess. So what I want you to do is off to the side, kind of up there at the left, we're going to do 2 problems. The first one, I would like you to write this. Capital T, and then kind of a subscript AB. The very back page. It's the last page. Yep. Last. Keep going. Keep going. There you go. This is our new notation for how to translate if it's off the grid. What this means is order matters. T means translate. AB means here's the direction you're going to slide it. You are going to slide your figure from A to B. So I'm kind of moving it northeast. So watch up here. Here's what you're going to do. In a second, you are going to trace the triangle. Now, you're going to use that patty paper for 3 different figures, so don't put it right in the middle because you'll run out of paper. Maybe do it at the top. You are going to trace it out, and on the inside, you're going to write your points because you're about to cut it out. And then we're going to actually get to just trace and move up from point A to point B. And that's where it's going to slide. slide. So everybody right now, trace it. Put the points in the inside, so when you cut it out, they're already in there. Oh, sorry, I might have ran out of scissors. Some people may have to share. Anybody not have scissors? Go ahead. Trace it. Put the points on the inside. Cut it out. I'll show you again how we're sliding it. Cut out the triangle itself. Yep. All right, here's what I want you to do now that I think we've all got it cut out. Place your cutout right over top of your original figure. Now you're going to do what this says in this order. So you're going to move A to B. So mine's going to look like this. I'm going to take point A and move it up to B, and I'm done. That is my translation. I just need to make sure to now trace it on my paper. I'm about to move that patty paper. And I'm going to name my new points A prime, B prime, C prime. I'm going to put a 1 in the middle because that's my answer to my first question. Question number 2, we're going to use this same paper. Lay it back over the original. This time, here's what I want you to do. Translate, let's go CB. So take C, move it to B, so you're moving it sort of northwest. Every point's moving up there that same way. And then we call our points. You can't call it A prime. We already have an A prime. So A double prime, B double prime, C double prime. I put a 2 in the middle just because that's my answer to question number 2. Any questions on this one? Okay. Take your patty paper and go ahead and start tracing, labeling, and cutting out the trapezoid. You're done with that triangle. Question number 3 is going to be this. I want you to translate EF. That doesn't mean we're just moving points EF. That means we're translating in the direction wherever E to F is. In this case, we're going east. There is some overlap. There should be. Question number 4, same image. Let's go with translate GF. G is going to F. Let's see. Do you think that's something you could do without the patty paper? It's totally up to you. You just think about sliding it, and you can do it with or without. I'm going to give you 2 questions now for the last one, that hexagon. So we're done with the trapezoid. I'll walk around and make sure we're good on these. Go ahead and start tracing out your hexagon. If you want to try it without patty paper, that's fine. I will put up the 2 problems I would like you to do. Any leftover patty paper could get thrown away, or you could save it for your homework. If you're at home, you can use wax paper, or it doesn't really have to be see-through. It's just helpful for tracing. You could use regular paper.